In number 2, we want to evaluate the expression without using a calculator. So, in number 2, we have the inverse sine of square root of 2 over 2, and we want to find out what angle represents this expression. So I'm going to take my unit circle, I'm going to scroll out here a little bit, and I want to find on my unit circle where I have the sine value that is positive square root of 2 over 2. So if I go around, remember my x is my cosine, my y is my sine values. So if I go around my unit circle, I actually find two values, two angles that have the square root of 2 over 2 as my sine value. That happens at 45 degrees and it happens again at 135 degrees. So in this case, I have two answers I can write down, 45 degrees and 135 degrees. Okay, but I can only have one answer. So we have to go through and we have to figure out which of these two works and which one doesn't. So I'm going to pull out another unit circle here, and I know we've had some conversation about this, but I want to make sure we go over it again. In my unit circle, I have sine, cosine, and tangent. Those have been the three main trig functions that we've been focusing on. My sine values are positive wherever my y value is positive. So remember, my cosine is my x, my sine is like my y, and my tangent, if you remember, is actually my y over x. And we'll get to that in a little bit. But we're focusing right now on sine and cosine. So my sine values are always positive where my y values are positive, and my cosines are always positive where my x values are positive. Okay, so sine is always positive in quadrants 1 and 2, and my cosine is always positive in quadrants 1 and 4. If you can remember back to probably late algebra 1, you talked about what inverse functions are, and you probably talked about them more with your linear functions, so with your lines. And with your inverses, you found inverses of linear functions by substituting or swapping your x and y values. So if you kind of think about this a little bit, you kind of swap on the y equals, well, we'll talk about that in a little bit too when we talk about tangent. But cosine and sine, my x and y, we kind of swap those values when you're looking for inverses. So we're going to try to make this a little easy to remember. My sine inverses, okay, so my sine values are positive in quadrants 1 and 2, which means my inverse sine functions is when I swap the two, so my inverse sine can only occur where my cosines are positive. So my inverse sine functions can only occur where my cosines are positive. At the same time, since my inverses mean I swap my x's and my y's, my cosines, my inverses of cosines, can only exist where my sines are positive. So inverse cosines can only exist where my sines are positive. So in this case, if I'm looking for the inverse sine of square root of 2 over 2, like in the warm-up number 2, out of my two values, I can only pick the angle that exists in quadrant 1 or quadrant 4. So which of these two, 45 degrees or 135 degrees, occurs in either quadrant 1 or quadrant 4? And that would be 45 degrees. So my answer for number 2 is 45 degrees.